Hey everybody, hope everyone is doing well today. We are going to be discussing addition on a number line today, and the target that we're going to follow is 2.NBT.5, and that says I can fluently add within 100 using strategies based on place value, properties of operations, and or the relationship between addition and subtraction. But today we're just going to be focusing on addition on a number line. And this is really helpful because when we think about adding and subtracting, we're really just moving forward and backwards on a number line. And I'll show you an example in just a little bit. But first, I want to discuss some vocabulary that is very important for addition. So the first term I want to talk about is sum. S-U-M. And that word means the sum is the answer to an addition problem. So you'll see questions that say determine the sum or find the sum, and that means we need to add. We're going to find what the answer to an addition problem is when we hear the word sum, S-U-M. Another word that is important is add-ins. And add-ins are two numbers that you add together to get a sum. So if I have 1 plus 2, 1 and 2 are my add-ins because those are the numbers we're adding together to find our sum. So what would the sum be in this case? 1 plus 2, well, we know that that is equal to 3. Now, another term that is important that I just said would be equal. Well, what does equal mean? Well, equal means the same amount, or the value is the same when two things are represented. So when we have 1 plus 2 equals 3, those two things on each side of this equal sign need to be the same. So let's do a visual representation of that. So if we have 1 plus 2 equals 3, we're going to use dots here. Like think we have counters. So there's 1 to represent the 1, 2 for the 2, and then for our 3, we're going to do 3. Now, we want to make sure that there's the same amount of dots on each side of this equal sign. Now, in this case, there is, but when we're working with some harder, more challenging math problems, we want to make sure that there's the same amount on each side, so everything's balanced. If you had a scale, you all have used these in class sometimes. If you have a scale, you want to make sure that there's the same amount in each, so this scale is flat and balanced. So sum, the answer to an addition problem, add-ins, two numbers that you add together to get a sum, and equal means that the same amount or the same value is represented on both sides of our equation. Okay? Now, getting to the number line. When I add on the number line, there's different strategies you can use. There are different ways you can do it. Here's how I like to start. This is an open number line, so it doesn't matter where we start. But we know when our numbers are getting bigger, our numbers get bigger as we go from left to right. Okay, so you know this from working with number lines in the past. If we had number lines, we would, if we made marks, we go 1, 2, 3. They would just keep getting bigger and bigger and bigger as we move from left to right. So what I like to do is find my biggest add-in. So I'm going to underline my add-ins. 34 and 27 are my add-ins. And we see that 34 is bigger. So that's where we're going to start on this open number line. So we can imagine that we've already jumped up 34. We're going to start here. Now what I'm going to do is I'm going to break up this 27 into tens and ones. And we can put it in expanded form. So 27 is 20, and then plus 7. So at some point we can make jumps of 10. How many jumps of 10 can we make with 20? Well, we can make two, right? There's 10 and 10, that's 20. And 7 we can break up into 5 and 2. We can do 7 ones. We can approach that many ways. I'll probably just do ones at this point. So 1, 2, 3, 4, 5, 6, 7. Just do 1, 1, 1, 1, 1, 1, 1. So these are the jumps that I'm going to make here on my number line. So first, let's do our tens. So I'm going to do start at 34. I'm going to make a jump of 10. So I'm going to put plus 10 because I'm getting bigger by 10. Okay, so 34 plus 10. And every time you make a jump and you hit the line, you touch that line, we need to put a number underneath here. So 34 plus 10, my tens place is going to get bigger by 1 digit. So that would be 44. Now, so we've taken care of this 10. Now we have one more 10 to jump. So I'm going to make another jump of 10. And I touch the line here, so I'm going to make a little box. You don't have to make a box. I like to make a box sometimes when I'm starting out to make sure I don't forget to add my numbers. So now we're going to start, we were at 44 and we jumped another 10. So my tens place is going to get bigger by 10 more. So I'm going to be at 54. Okay, so now I've taken care of that 10. So what I have left is to make 7 jumps of 1. Okay, so 1, 2, 3, 4, 5, 6, 7. And we can count up. We're going to count up by 1. So 54 and 1 more is 55. And then, so there's 55. Then her 56 right here. 57, 58, 59, 60, 61. Okay, so that is an example of how you can make a jump of 27, make some jumps of 27 when we're adding 34 plus 27. That's one way you can do it. There are different ways, and we'll practice some examples, but this is the most basic way. Take your biggest add-in, break your second add-in up in expanded form, and you can break that down into tens and ones, and then make those jumps. Another example, we have 14 plus 43, and we're going to find the sum. Again, I'm going to use, it doesn't matter which order you go in addition. You can start with either number. So I'm going to use 43 as my starting number since it's bigger. So this open number line, you can start it wherever. We're getting bigger, so we're going from left to right. So now I'm going to add 14. So let's break 14 down. So if we do expanded form, we have 10 plus 4. And we're not going to break that down any further because we want to make jumps of tens and ones. So if I make a jump of 10 starting at 43, hit the line and make my box. 43 plus 10, our tens place is going to get bigger by 1 digit. It's going to be 53. Let me write that again. It's going to be 53. And then I'm going to make 4 jumps of 1. So 53 was our jump of 10. So 54, 55, 56, 57. And this 57 would be our sum, because that's the answer. So there are 2 quick examples. We'll practice this some more, but I hope this is a good introduction and to see how we can add on a number line.